Good afternoon and welcome to this video demonstration of Lab 10.1.1.13. Um, this is one that I actually did as a packet tracer myself when I was taking this course. There's a very similar exercise called 10.1.1.12 that does more or less the same thing. It even has the same uh, addressing scheme. So if I go up here, this is my PDF, as of course, with all of these labs which we're doing in Packet Tracer from scratch, in lieu of the exercises we would normally do on real equipment in the live lab. We're doing all this in Packet Tracer, of course. So let me find that. So this is the one I did. It did not take me 2 hours. This file has been open for a while. As you can see, it's the same topology. The only real difference is the naming of the devices. So now I'm going to demonstrate this. I'm going to close this out. No. Okay, so here we have the topology. Don't let the fact that I've physically arranged them a little bit differently confuse you. I just wanted to do this to make the port choices a little more obvious. Now, the thing to note here is that these port choices don't really matter. I mean, the gigabit interfaces on your routers, of course, matter, but the exact switch you use is somewhat less important. I picked actually, let's look at it. Go to the, okay. I picked a 24 port 2960. I could have picked a different switch and it would not have made any difference because the switch is practically invisible for our purposes here. All it is a layer 2 device to get all three of these routers in the same subnet, same broadcast domain. Well, no, obviously not the same collision domain because we are talking about routers. Now, the one thing you might note is that this switch doesn't have any gigabit ports on it. So yeah, if I really wanted to optimize this and minimize the possibility of um, collisions, I could tune the speed of these gigabit ports down to 100 megs, 100 megabits per second, the fast Ethernet speed. Alternatively, if you've got a version of Packet Tracer which affords you the ability to drop in, say, a 3560 or 3650 with gigabit ports on it, everything can run at wire speed, and that's fine. Now, but as I said, the switch is not the point. The point is build and configure your basic devices, then we'll set up OSPF v2 on all three devices. Then we're going to set up the interface priorities so that we can decide how the devices elect amongst themselves. So step one is the usual stuff. And of course, as per usual, I've got my setup ready to go. There's really no point in, as I've said before, in knocking this all out by hand. So I'm going to copy and paste. Boom. So now the only thing it didn't like was that I had this enable down here. So I guess I'll change that. Didn't like that. Now, if you do that, if you get all the way out, save at some earlier point in this for whatever reason, you'll have to of course, get back into enable mode. But really, okay. And as you can see, I've already got the other code written. And I'll go to router 2. And actually, you know what? Make this smaller. Because all I really need to do is look at this every once in a while. Router 2 and router 3 and boom. And really and truly, I guess I can do this. Boop, boom. Oh, yes, good. Now, drag down. down. Okay, there. That'll make it easier for me to see all of this. And now let me get my topology back. No, not that. Because I do really kind of want to see everything all at once, as much as possible. So router 3, command line. Oh, wait, I haven't done router 2 yet, have I? Oh. And router 3. Okay, so there we are, most of the way through part 1 already in 5 minutes. Now the next part, of course, is the interface addressing. Each device is going to have one interface going into this subnetwork here and another loopback interface. Now, we're not actually, when we look at the OSPF implementation, we're not routing, we're not advertising those loopbacks at all. So let's do this. And now notice, because the way I've written my code, I have that no shutdown line explicitly stated, so that I don't just configure the interfaces and leave them dark. I configure them and bring them up immediately. I don't have that on the loopback, because on the loopback you don't need it. The other thing to notice here is the loopback is using a /32 mask. If the loopback only exists for itself, there's no reason not to configure it that way, so that it really does properly simulate it doesn't attempt to simulate an entire network. It is just that one address. Let's see. Okay, and now I'll do the same thing on the other two. Copy. Okay. Now, router 3. Same story. Now, so I've got, okay, right, why is router 2? Oh, that's why. Because I put it on the wrong interface. I was not paying attention. I used gig 00, so obviously I need to put it back. So int 0, no desk, no description, no IP address. Now let's do show run right quick. Do show run pipe begin interface. There. So gigabit is blank. So I can move all this, I can do this same configuration that I should have put on gig 00 on gig 01. And of course, I'm not going to put the loop back in because I just did that. And we're live. The next thing to do is ping everything. And I'm going to go over to my addressing table right quick. Okay, so I'm here. I'm here, router 1, which means I need to ping 1.2 and 1.3. Okay. If I really wanted to do this, I could do this from all 3 of them at the same time. But let me show you something. Do show ARP. So I've got ARP resolutions on all 3 of these. Strangely enough, I've got my own ARP resolution, and I've got 1.2 and 1.3. Let's do ping 192.168.30. Let's ping that loop back right quick to show ARP. Notice that there is not an ARP resolution on the loop back. That's because that ping to the loopback doesn't go any lower than layer 3. And that's always going to be true of a local loopback. On a distant loopback, it's going to have to figure out how it's going to route that packet. It's going to have to ping. It's going to have to figure out how to deliver that routed the frame for that routed packet out the exit interface. So it is going to have to do ARP resolution into an Ethernet network, or it's going to figure out have to figure out how to talk to the serial line. But in this case, it's a local loopback, so layer 3 is all as far down the stack as you go. So the next thing we want to do is implement OSPF. So I'm going to go back. I'm going to go back to my router. So I've done this. I'm going to configure OSPF part 2. I'm actually going to start on router 3, not router 1. We want to do this because by controlling the order in which we implement OSPF, we're controlling how the DR election process begins the first time. And then we're going to go back and do, pardon me, we're going to go back and put in priority values, which will change that calculus completely. So we'll start on router 3. I will go to my router 3, and I'll do router OSPF area 1. Okay, copy. So this is going to happen, but nothing else will happen after it until I start implementing router OSPF on the other devices. Paste. Boom. So I've declared router 3. So let's do show IP protocols. So my gateway address is, my address is 192.168.31.33. Why? Because I haven't set a router ID. And also because a loopback address trumps the trumps a physical address in router ID selection. Now this is why we're not advertising these loopbacks, because we're not using them as addresses. We're using these loopback addresses in lieu of the router ID configuration, which is completely legal for an IPv4 router. So let me go ahead and do OSPF on the other 2 devices, and that'll be the end of this video, and we'll roll on to the next one and start talking about the designated router election process. So 2. Boom. And it's going to start forming DR election pairings here in just a second, I should think. And I've done that. There it goes. Copy. So it has a neighbor now. And let's add the last one in. Paste. Boom. So now, so we've got our, let's do our show IP OSPF neighbor command on all 3 of these. And show IP OSPF. And actually, I'm going to put these side by side so you can see it. There we go. And there, we've got our neighbor relationships, and we'll start talking about what these mean right away, right after this break.